All right. So, good afternoon, everyone, or maybe good morning, good evening. Don't know where you are. I'm in Thailand. It's 4:30 here for me. My name is Tim Klappe. I am the managing director of MPS Systems in Asia Pacific. So my area is the Asia Pacific region. And today I would like to talk with you about how connectivity, the sensor technology, will transform and I think also will disrupt label print production. You know, this connectivity, this sensor technology is affecting all kinds of production. Yeah, people talk a lot these days about the smart factory, and that is really making an inroad in all manufacturing processes. But for me, I will talk about the label print production and what's going on over there. I would like to show you this picture of Formula One. And if you look at the top left corner, you see there are three experts watching a monitor. And what's happening, so these guys are getting a lot of input from the Formula One car. As a matter of fact, every Formula One car is full with sensors. And huge amounts of data is coming from the sensor. So, for example, the temperature of the brakes, the G-forces, the wear of the tires, vibration. I mean, this is all measured. So basically they get a mirror of the Formula One car, yeah? and digital twin, as it is sometimes mentioned as well. And they do this, of course, to win the race, but also to get more and more information so that they get better in future races. Yeah? So this is also used for research and development to get better and better and better. Now let's look at the label printing industry. So we have here also a very pricey machine normally. I mean, a label printing press can have a price somewhere between 300,000 euro and even 3 million euro. So that's quite a valuable machine. And at the moment, we don't get much information on what's happening in the machine. Of course, you get your speed and you get error messages, mechanical error messages or electrical error messages. You get some information about pressure, depending on the machine you're running. But you don't get information of how the machine is run. You don't get information about really waste that you're producing, or let's say how quickly you're setting up the components like the unwinder, the print units, the rewinder. You don't really know. So basically you're dealing here with, well, basically a black box. You can say, well, I have operators who are typing in the actions that they are doing. That is true. Some are doing that. But let's say they are giving 10 to maybe 20 actions that they are doing. They're typing that in. Not more, certainly not hundreds of measurements per minute. And if you see your operators doing that, it actually will take time. You know, walking from the press to the console where they type in the data, that is actually, in a way, time waste. They cannot do other things. So, yeah, that's interesting, because you, of course, want to know, this is your production machine. You want to run it full time. You want to know what's going on. And it's not a cheap machine. So why is that? And it's even more important because for us, we've analyzed many situations and we found out that many machines are not running that well. The utilization rate is rather low. Sometimes the machine is just running for around 30% of the time. Yeah, meaning 70% of the time they're sometimes not running. That's huge. If you want to earn back your machine that is worth maybe €1 million, of course you want to run that machine continuously. Yeah, you don't want to have those big breaks in between. Yeah. So look to a typical sort of period of a machine. After installation, so you have the ramp up, you have all kinds of peaks and valleys, quite a bit of downtime. And what you actually want to have is a more consistent operational bandwidth, desired operational bandwidth in which you want to run. So you need to know, why are those downtimes, those valleys here in these graphs? What's happening at the moment? You don't have all those data. So if you want to be on par with the Formula One industry, we need to mirror the printing press. We need to make a digital twin of the label press, and in such a way so that when we are starting with a setup, we need to know that we need to get all the signals from the time you load the wet in the unwinder to the setup of the corona treatment, the DLAM, the turner bar, the print units, etc., 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 until the unwinder. You want to know what's going on, because you want to know how long those components are taking to set it up, actually over time, so that you can analyze better uptimes, downtimes, good practices and bad practices. Yeah. So this can be done by having these machines equipped by hundreds of sensors. And these sensors will give, obviously, many more details than any operator can do by manual input. Yeah? And even if you have systems like CERN or label threads, which are very good systems, but they give information about what's happening around the machine, not what's in the machine. And you need to know what's happening in the machine if you want to increase your productivity. I will give you some more details about what kind of information you can get from this later on. Yeah. So what we need is a machine with all kinds of sensors, with a server that collects this data, and then of course software that is analyzing this data, so that you can get reports wherever you are in the world, as long as you have internet access. And it should really look good, the reports. Yeah. Let me give you a few examples of reports. Yeah? So this is an example of an overview of a wheat production. So those blue bars shows you the jobs, and the height of the blue bar shows you the speed. So it shows you also how many meters you have produced, the waste you have produced, the waste percentage, the efficiency, the utilization rate. So this gives a very good bird's eye overview of what's happening in a week. But you can zoom in and then sit, for example, with your team and say, hey, why are those gaps in between those jobs? And why are you running for 1 minute, 100 meters a minute? And other times you're running 120 meters a minute or 150 meters a minute. And what's going on? Maybe these are different substrates, different jobs, maybe fully understandable, maybe sometimes not. Why do you sometimes wait for more than an hour between jobs? Is it because the ink was not available? Was it because the print sleeves were not done on time? Could be logistical issues. Maybe that is an area that needs improvement. You can zoom in more in detail to the components. For example, on this slide here, on the left side, you see the rewinder. Changeover times, and on the right side the unwinder changeover times. Now, for example, take the unwinder. Some operators apparently do this in 1 minute, others are taking about 10 minutes. So why is that? It's a huge difference. If you can get these sort of worst performers to closer to the 1 minute, I mean, you could potentially save 8 to 9 minutes. That's insane. If you have like 10 jobs a day, that's like 80 minutes a day. Yeah. Even if it is just 1 hour a day, if you work 300 days a year, that's 300 hours saved. if you can run labels during those 300 hours, that's huge. We have customers where we can prove to them when you set up those different components more efficiently, you can really earn hundreds of thousands euros extra per year. So that's insane. And that's what we see when we analyze those environments. The biggest gains can really be found in finding those gaps in productivity. It's not like if you compare one machine with another, that one machine is, you know, a little bit better in you know, the speed of the servo motors or whatever it is. Of course, these things can be important, but it's the efficiency in operation that gives you huge gains, really hours a day and hundreds of hours per year, which gives you so much more time to run jobs and therefore more profits. So I just show you that slide where you compare jobs of one machine. But you can also do benchmarking. You can compare the operation of your machine with, let's say, the best in the industry. So this graph shows you three different machines. And again, there are big differences. This is an unwinder setup. You know, about 1 minute to again 10 minutes. So you can ask those best performers, say, so how are you doing that? Make a video of it. And that's what we do at MPS. We also make videos of setting up the different components by our staff. So of course our people, they know how to do that well with our machine. So they show a good performance. And this we can use to train the operators and then really move them from average or sometimes below average performance to a good performance, and save hands and hands full of time per component, yeah? So in a nutshell, this press mirroring or this creating this digital twin of your press really gives you transparency in your production, yeah? Real-time transparency. Really at any time of the day, wherever you are, you know what's going on with your machines. Not because the operators are telling you that, but because the sensors are giving you this feedback continuously, streaming data. Yeah. Now then you can of course benchmark your own operators or benchmark with the industry leaders. That gives you the bottlenecks, the gaps, the areas where you need to improve. And of course, also the areas we are really good at. Now, that needs to lead to plans of actions. And those plans of actions gives you these improvements in productivity and all based on facts, on really accurate data, not subjective. This is all facts given by the sensors in the machine. So all this, of course, leads to higher productivity and higher profit. So transparency, benchmarking, you identify the bottlenecks, you make plans for improvement, and you get higher productivity and higher profits. Now, this is really good, of course, and I can tell you this is all available today. Yeah, for MPS, all our machines are being delivered these days with these kind of technologies, with servers, with the sensor, so report possibility. So it's all there. And we also help our customers in analyzing the data. So we have teams coming from different disciplines, data analysts, print instructors, engineers who are looking to the reports and say, okay, here there is room for improvement and that can be done. And we will have sessions with our customers to discuss this. Now, it's all great, but it's very important that the printer, our customers are really doing something with it. You can have great reports, but if you don't have a mindset and culture in the company of continuous improvement, yeah, then of course not too many positive things will happen. Yeah, so I really like what the Japanese are doing. Yeah, this Kaizen concept, this concept of continuous improvement. This is really important to take the most out of these new technologies. So press mirroring, the digital twin, it's all available today. And I think it's a must for companies to go into this. I mean, if you look to other industries, you look at the self-driving car, the planes which can go up and descend properly without pilot interventions, and in retailing, in the medical sector. The Internet of Things is really growing very far. And if you look to our industry, the smart printing factory, where not only the components of the machine are talking to each other and giving feedback, but you can go much further than this. And if you look to flexo printing, label printing, a lot of knowledge is available in pre-press. You know the quantity, you know the inks to use, the quality. So you could already give signals to the ink trays, how much ink there should be in the different units to run this job. Subsequently, there could go a signal to the local ink factory in your company. You know, signals could go to your customer, to your supplier. And technically, this is all possible, and this will happen. So again, I think it's very good to know more about this and make at least small steps in your organization to implement continuous improvement. And when you have a chance to invest in new equipment, please think about investing in these machines with the sensor technologies that enable press mirroring. It is an enormous, useful tool to get to higher profits and higher productivity. So I totally believe that this technology will transform label printing and actually disrupt it when, you know, with all these new developments that are going on at this moment. So with this, I would like to finish my presentation, and thank you very much. And if you have any questions to me, please ask. Let me put myself, or let me show all the participants.